Do you know what an electrical substation is? Today we're going to explore how substations work and why they are one of the most important parts of the modern power grid. You've probably seen these massive facilities filled with transformers, towers, and high-voltage equipment. But what exactly do they do? When you plug an electrical device into an outlet, the electricity powering it usually comes from a power plant located many kilometers away. However, electricity cannot travel directly from the power plant to your house without passing through several stages. The electrical grid is divided into three main parts: generation, transmission, and distribution. Electricity is first generated at power plants such as hydroelectric dams, nuclear plants, wind farms, or thermal stations. After generation, the electricity must be transmitted over long distances to cities and industrial areas. Finally, it is distributed to homes, businesses, and factories. Substations are the critical connection points that make all of this possible. One of the main functions of a substation is circuit switching and isolation. Large cities are usually supplied by multiple transmission lines. If one of these lines develops a fault or requires maintenance, operators must isolate it without shutting down the entire system. This is done using devices called disconnect switches, which safely separate parts of the grid while allowing electricity to continue flowing through alternative paths. Another essential function of substations is voltage transformation. Electricity generated at power plants is typically produced at relatively low voltages. To efficiently transmit power over long distances, the voltage must be increased to extremely high levels such as 138,000, 230,000, 500,000, or even 750,000 volts. Higher voltage reduces energy losses during transmission. Near cities and residential areas, substations perform the opposite process by reducing transmission voltage to distribution levels suitable for local networks. In many countries, distribution systems operate around 13,800 volts before the electricity is finally reduced again for household use. This voltage conversion is performed by transformers. A transformer is a device that uses electromagnetic induction to increase or decrease voltage. It contains two coils of wire placed close together. When alternating current flows through one coil, it creates a magnetic field that induces voltage in the second coil. The ratio between the number of turns in each coil determines whether the voltage increases or decreases. Substations also play a vital role in protecting the electrical grid. Faults such as short circuits, lightning strikes, or damaged transmission lines can cause dangerous surges of current. Protection systems are designed to detect these problems instantly and disconnect affected sections before damage spreads through the network. The simplest protection device is a fuse, which melts when current exceeds a safe limit. However, large substations mainly rely on circuit breakers. These devices operate like the breakers found in homes, but on a much larger scale capable of interrupting enormous voltages and currents. When a circuit breaker opens, an electric arc can form between its contacts. This arc must be extinguished quickly to avoid equipment damage and ensure worker safety. For lower voltages, breakers may operate in vacuum chambers. For higher voltages, they are often submerged in insulating oil or use dense dielectric gas to suppress the arc. Modern substations also use protection relays. These electronic devices constantly monitor voltage and current levels throughout the system. If abnormal conditions are detected, the relays automatically send signals to open circuit breakers and isolate the faulted section. All major equipment inside a substation, including transformers, disconnect switches, and circuit breakers, are connected using bus bars. Bus bars are thick copper or aluminum conductors designed to carry extremely high electrical currents safely. Their arrangement is critical because it directly affects the reliability and flexibility of the entire substation. The bus bars are mounted on large insulators that support the structure while preventing electricity from flowing into the ground. Without proper insulation, high-voltage conductors could create dangerous faults and outages. Substations are among the most important engineering systems in the world. They allow electricity to move safely and efficiently from power plants to millions of people every day. Without substations, modern cities, industries, hospitals, and communication systems simply could not function.